Good day all. Today we'll be looking at polar plots. So we'll be talking about it with an example. Now the normal graph that we normally plot, which is your x and y axis, you have here to be your x axis and here to be your y axis, and they will give you a table x and y, and they will say 0, 1, 2, 3, and then your y will also be given, let's say 2, 3, 4, 5. Then with these values you plot on your graph, and you plot on your graph, you keep plotting on your graph just in that order. So where you see 0 for x, you say this is your 0 for x. Then you see that your y is what? 2. So you then find your y. You call here a point. You say, where is your 1 for x? You can call here to be your 1 for x. Then where is your 3 for x? Just like this. So each of them, this is how we normally plot our normal graph. This is our x and our x and y axis graph. Now, the reason why I'm bringing this up is because your polar plot is just the same thing, but the only difference is that we're no longer plotting real numbers, but what complex numbers now. Now we are now plotting values that now have imaginary numbers in it. So something like, let's say 2 plus 2j, j2, something like this. We're not going to be plotting its graph, which is there's nothing hard about it. The only thing that is a bit different from this is that in this one you're plotting your y against your x. Why in this place you plot your imaginary, which is this one having the j, against your real numbers. So if you are asked to plot something like this, you can then you just simply say, for your imaginary, you point out your what? 2. For your real, you point out your 2. Now you have plotted this graph. So this is just what your polar plot is all about. It's just plotting complex values or variables given to you. So I want to make that clear. So that's what we are going to be doing today. Now, but we're going to be doing this using transfer functions. Now this our transfer function was given to us like this. Now we'll first convert it and change it to its frequency domain form. And when we do that, we have that g of jw is equal to 1 over, in place you see s, you replace it with jw. jw brackets 1 plus jwt. So there are two ways you can plot this graph. You can do a rough sketch using knowing some few parameters, but today we're not going to be using that. Instead, we'll be using the other method, which is what? Direct plotting. We're using the direct plotting method in this case to solve this question, to sketch our polar plot. So the idea here is to remember, like the example I gave, I said something like 2 plus 2j, where here is your real number and here is your what? Imaginary number. So the idea here is to separate this guy so you can have your real number, which is the one that doesn't have j, from your imaginary number, the one that has what? J. So that is our focus here. We are trying to find a way to split this into 2, with the real number being on its own and the imaginary number being on its own. So we will take a step further and say this is equal to, now first of all open the bracket, we will have jw plus, you can say j square w square t. We're not having t square because what? There's no t here. So this is multiplying everything in the bracket individually. So we know that j square is equal to what? Minus 1. So when you substitute that here, you have that the whole of this is what? Minus 1 in brackets. And when that minus 1 multiplies this plus here, this also changes. This also changes to what? Minus sign. To what? Minus sign. Now, this is we're only what we have done now is just to open this bracket, and when we did it, we got to this point. That's what we have done so far. Nothing else. Now we can go a step forward. Now, what the next thing we'll be doing here now is to find the conjugate of this denominator in our normal complex in our sword. I think this is under either sword or complex numbers. When you have something like, let's say 2, okay, let's say 1 over root 2. If you input this in your calculator, you see that your answer will turn out to be what? Root 2 over what? 2. So what they simply did there was what? They multiplied the numerator and the denominator by what? Root 2. The idea is to eliminate this sword symbol at the denominator. And when they did it, 2 times root 2 times root 2 will give you what? Root 4. Square root of 4 is what? 2. So you have eliminated it, getting this. Then your root 2 will then multiply your 1 on top, getting this. So this and this are what? The same. Remember, the thin line between sword and your complex number is just, in fact, the square root of what? Minus 1 is what? I or j. Whatever you choose to represent it is what? J. So that's just the slight difference between, if you have a little knowledge on sword, complex number shouldn't be much of an issue. So the same idea that we applied, we are going to, well, this time around, we're having what? Minus. And for us to find the conjugate of, let's say 2 plus all over, you can also try to impute this in your calculator and see what the answer will give you. But how we solve this is, we will multiplying both numerator and denominator. We'll be changing this side as the front of the words, the sword symbol. We'll change it to what? Minus over 2 minus what? Root 2. So when this multiplies this, you have what? 4. When this multiplies this, you have what? Plus 2 root 2. When this multiplies this, you have what? Minus 2 root 2. This multiplying this, you have what? Minus root 2 or what? Square. This will be multiplying this. The minus, remember, is outside, not inside, so the square won't be affecting it. So the square root of this root, this we cancel out this, and we'll be left with what? Just what? 2. So minus 2 plus this is plus 2 root 2 minus 2 root 2. So this and this will cancel out, and we're left with what? 4 minus 2 at denominator. Now for the numerator, we'll be having what? 2 minus root 2. Now 4 minus 2 is what? 2. So if you press this in the calculator, you're going to be having 2 minus root 2 all over what? 2 all over what 2. How we got our 2 here is 4 minus 2. We got this. So if you put this in a calculator, this is what you're meant to be getting. If you input this in a calculator, this is what it will give you. Something like this. So we call this conjugation. The idea here is to eliminate either the square root or this imaginary symbol, to remove it from the denominator and take it to the what numerator. That's just the idea. So you can still rearrange this or continue solving like this, but let's rearrange it. You can rearrange this to be 1 over minus wt plus jw, and this is our target. So we'll be conjugating by what? Multiplying the numerator and the denominator by what is conjugate. Now, when this multiplies this, you have what? Minus omega square t minus j omega over, this has multiplied this and we got this. Now this is what multiply this. Now this times this is what? This times this is going to give us minus w2 square t all squared. This multiplying this, we have what? Minus j, not going to be cube. Remember, this is multiplying this, so we had one omega here, and 2 omega here, so it will become what? 3. The power of 2 here, the power of 1, so multiplying, they will add up. Now we have this. Now another again we are going to do is now this one times this one. We are going to be having what? Plus jw omega what? Raised to power 3 c. And then finally this multiplied by this will be having minus j omega all what? Squared. This can cancel out this because they are what? This is, we're having something like minus, like you have it minus 2 plus 2. So this will definitely give us what? 0. That's what's happening here. They are alike and they're having different signs, so they're going to cancel out. But for this place, if you have to open this bracket, you'll be having j square, and our j square, like we said earlier, our j squared is equal to what? Minus 1. So we'll be replacing that. So we'll be having some, and coming over here, we'll be having something like w. This is, the minus is affected by the square, so it's going to go out. W 4t square minus, we say that this is going to be giving us what? Minus 1. The square of j is what? Minus 1. Now the square of omega is what? Omega what? Square. Your minus will multiply your minus in this one and changing it to what? Plus. So you end up what? Having what? Plus here. Remember, this is just the continuation of the denominator. So when to equate your final answer, you'll be having something like minus wt minus jw over w raised to power 4 t raised to power 2 plus what? W square. W what? Square. Now continuing from here, this is our questions. Let us leave this behind first. So continuing from here, we can see that w are in each of them. So we can factor out w in each of them. For the numerator, if you factor out only w, we'll be having minus W T. So it's raised to power 2. So if you are removing it, only 1 will remain. Minus what? J over W square is here. W is here. So you can still say W square. Here will be what? W square T square minus what? 1. Minus 1. So I have not done anything extraordinary here. It's just the same thing. So our W, we have W here, we have W here. We brought it out. When we brought it out, only what was left there was J. Brought this one of this one out. What was left was only one W inside. The other one was out. Here we brought out 2 of the W out. When we brought it out, what is remaining here is what? What is remaining here is what? Only 1. Now when we brought out another when we brought W out from this place, what does mean was now W raised to power what? 2. So this we cancel one of this one and we are left with what? Minus W C minus J all over what? W square C square plus what? 1. So we have gotten to this. So we have succeeded in changing this J that was at the denominator. We have succeeded in taking it now to the what? Numerator. So that's the main idea here. We've taken it now to the numerator. Now, normally when you want to solve your fraction, let's say 1 over 2 plus 1 over what? 2. When you want to solve this and you have a what? A common denominator in maths, they will say that since the denominator are what? Common, you can do what? Take one of them and then solve your math. Say when you be dividing, you have this divided by this, you have 1 times the one on top, you have 1 plus this divided by this, you have 1 times the one on top, you have this. So you can just see now that this, the only difference from this and this is that they collected the denominator to be 1 while your numerator still remain what? Separated. Now looking at this one, that's the same thing we are going to be doing here. We're going to be splitting it now. And when we do that, remember we want to separate our J from our real numbers. We'll be having minus W T all over W brackets W square T square plus what? 1 minus J over W brackets W square T square plus 1. So I succeeded in doing what? In splitting this into 2. Now we now have our imaginary number to be on its own and the real number to be on its own. Okay, so now we can take another step forward. We can say that since we are having W here, W here, if we are to cancel out, we have that this is going to cancel out this one. We have that what? Minus T over W, sorry, this has gone out. So we're going to be having W square T square plus what? 1 minus J over what? W bracket W square plus what? 1. So this is what we have been trying to do, what? To get. We have succeeded in getting it now. Now the main thing now that the question was demanding from us was to sketch the polar plot of the transfer what? function. So we're going to doing a sketch on it. So this is what we wanted. Now another thing that we need before we can plot is to first of all get values that if we impute in this formula can give us an integer, can give us an integer. We don't want to see variables in that formula, so we'll be assuming that w, we assume w to be first 0 and next one infinity. We'll be assuming that. Now sorry, let me take this up. So we have assumed that let our zero, our omega, which is our w, to be what, 0 and what, infinity. Now let us also assume for our real values, remember this is our real value, the one that doesn't have j, and this is our imaginary what, value. Now for our real value, we're going to be imputing w into it to get our values, and for our what, imaginary. So this is what we're going to be using to plot our what, our graph. So the polar plot of a transfer function normally ranges from 0 to what, infinity. There's nothing like minus infinity in this case. We're starting from 0 to what, infinity. That's what we are interested in. So imputing the value of 0 into this, you say 0 times your t square will definitely give you what, 0. 0 plus 1 is what, 1. Let me solve the thing. Let me write the thing down. So for our real parts, we have what, minus t. We're solving for when when omega is what, 0. So we're going to be having 0 what, square t square plus what, 1. This times this will definitely give us 0. 0 plus 1 is 1. So we're going to be having minus t over 1, which is something as what, minus what, t. As you can see, we are getting our distance to be what, minus t. Now doing the same thing now, or this time around, we're going to be doing for what, infinity. For infinity, so putting infinity here, infinity times t will give you what, infinity. In fact, infinity square is infinity, infinity times t is infinity. Anything times infinity is infinity, but anything divided by infinity is 0. So infinity times infinity times t is infinity. Infinity plus 1 is still what, infinity. Now infinity divided by t will then give us what, 0. Remember, if we are to say a number a multiplied by what, infinity, to definitely give us what, infinity. But if you're having a over what, infinity, this is definitely what, 0. Now infinity plus or minus any number, just say a, will still give us what, infinity. So for this one, for infinity one, we are getting our answer to be what, 0. We're getting our answer to be what, 0. So now let's solve for the imaginary parts. For the imaginary parts, we have minus j over, sorry, we won't be putting our j. We won't be putting our j this time around. So it will be minus 1. Our j is to show that that is what, imaginary. Is to show that this is what, imaginary. So minus 1 over our w being what, 0. We're going to be having 0 brackets 0 square t square plus 1. Definitely this multiplying all this will give us what? 0. And anything over 0 will give us what? Infinity. So we'll be having here to be what? Infinity. Now, for when w is what? Is now infinity. For where w is now infinity, we have infinity multiplying all this. So anything multiplied by infinity is still what? Infinity. And anything divided by infinity is what? 0. So here will be what? 0. This multiplied by this will give us what? Minus 1 over infinity. This divided by this will give us what? 0. So this is the values that we have gotten. These are the values that we have gotten. Sorry, there's a mistake I made earlier. For the zero part, we are having what? 0 brackets 0 square c square plus what? 1. Now 0 times everything here is 0. Anything divided by 0 is infinity. We forgot our what? Our minus sign in front of here. Forgot our minus sign here. So this is going to be giving us what? Minus infinity and not just infinity. So we have gotten our, this is the main thing that we're interested in, to get this table. Now with this table, now this is what we're going to be using to plot. We'll be using that table now to do what? To plot. So we will then say in our table, here is our what? Real numbers. Here is for your positive real numbers. Here is for your negative real numbers. Here is for your positive imaginary numbers. Here is for your negative imaginary what? Numbers. Now we'll then say when the real number is what? T. Is what? Minus t. So let's say here is our what? Minus t. Let's call here what? Minus t, because it's definitely going to be at the negative part. Our imaginary number is going to be what? Minus infinity. So minus infinity will definitely be to infinity. It will definitely be what? To infinity. So we'll just trace our line. Oh, we don't know where infinity will be. We don't know where infinity. We will just decide to just call here infinity, but we don't normally see infinity. So you don't know a particular value to give it. So we just trace our line downward to show that it is infinity. It doesn't have an end. It continues. So to maybe if they tell us to give us a particular value for infinity, that's when we can then find join it to get our normal point. But for now, since it's infinity, we'll just trace it down to it meets infinity. Now for the second one, our real number, they say is what? 0. Our real number is what? 0. And our imaginary number is what? 0. So at the end of the day, you will have that your graph will look something like this. It will start from, remember, it will start from what? From 0 to infinity. That is how our graph normally moves. So it is going to start from, so when 0 is, remember, your graph W starts from what? From 0 to infinity. So when W was 0, we see that we're going to be starting for what? Infinity. So let us say here is our infinity. There, when the thing is now ending towards when it is now coming, when our W is now coming to infinity, to then be coming towards what? 0. So this is how our graph will look like. This is how our polar plot will look like. So as W is getting close to, in fact, as W is 0, at 0 you start from what? Infinity. and be coming. Oh, so till it passes 1, 2, 3 to infinity. As it's getting to infinity, the thing is landing at what? 0. So this is a kind of a rough sketch or a graphical representation of your polar plot. But what we did now is just for the what? The direct plotting. So that's all for this video. Please subscribe to the channel, and if there's any place that is confusing, you can drop it on the comments so that the next video I'll make more emphasis on it. Thank you and God bless you.